Customs agents intercepted a balloon filled with a suspicious gas. If the gas has a molar mass of 44.01 grams per mole, which is the molar mass for carbon dioxide, and the ambient conditions are 0.98 atm and 273 Kelvin, what is the density of the gas inside the balloon? So they're giving you several different numbers, right? They're giving you the molar mass. They're giving you the pressure, the temperature. They just want to know what's the density. This is the formula that you all are going to use. Density in this case is equal to the pressure times the molar mass divided by the gas constant times the temperature. All right, so right here, you've got 0.98 atm times the molar mass. Now, if I did not give you all this number right here, guys, you see this? Let me zoom in so y'all can see. See, Nick says, what is molar mass? Oh, see, right here. I'm glad you asked, right on time with your question. If they did not give you the molar mass, which is the weight of the compound, you would have to find that in order to do this next part right here, to fill in this blank. So molar mass is the weight for the compound. So if you go to your periodic table and you find carbon on your periodic table, carbon's weight is 12.01. Then you also have oxygen, but you have two of them. The weight for oxygen is 16.00. Well, when you add those two numbers together, you end up with 44.01 grams per mole. Okay, so that's how we calculate the molar mass. This is what you need to know. The difference between molar mass and atomic mass, they're pretty much the same. However, atomic mass units would be 44.01 AMUs. So one deals with atomic mass unit in terms of the unit associated with that term versus molar mass, that's the grams per mole unit, but they mean the same. It's kind of like 44.01 atomic mass units also is the same thing as saying 44.01 grams per mole. We often use grams per mole when we are dealing with conversions of stoichiometry. Now, I've already given you that, so you don't have to worry about calculating that in advance. But if we did not, because sometimes, depending on the level your teacher wants to go, they may give you that as an advanced problem. And it's not really advanced in the sense of being hard. It's just that I'm going to give you an extra step to do to solve the problem. Okay, so as you plug in your numbers here, like always, go back and make sure that you cancel out your units, and because that's going to also check your steps to ensure that you are using the proper formula. If you get rid of your ATMs, get rid of your moles, get rid of your kelvins, density units are, y'all should remember this from the beginning of the semester, is grams per liters, grams per milliliters, and there you have it, okay? So what you're going to do here is multiply everything that you see, all right? Top row, bottom row, to get your density. So we just multiplied and divided those numbers, and there we have it, 1.92 grams per liter is the density of that gas. All right, 1.92 grams per liter. That is the density of carbon dioxide based on these conditions. All right. Number 4 is asking us to find the moles. Okay, so let me go ahead and go back to one of the former problems that we did before. This is the unit here for moles, right? N equals PV divided by RT. All right, PV divided by RT. If you can automatically write these down, y'all know my spiel, write these down on index cards, that's going to help you each and every time. All right. Let's read the problem though to make sure we're working with the right unit, the right formula. A patient performs a preliminary function test. Pulmonary means lung test. They exhale 3.5 liters of breath into a collection bag at body temperature 310 Kelvin and a pressure of 1.0 atms. How many moles of gas did the patient exhale? All right. So we know we got, 3.5 liters of breath. So I'm going to go ahead and plug the numbers in to our formula. We got 3.5 liters of breath, okay? That's for your volume. The pressure was 1.0 atm. The gas constant, 0.0821 liters dot atm per mole dot Kelvin. And then your temperature, 310 Kelvin. All right. Now, what you're going to do, you're going to go ahead and, like we always do, get rid of the units that you do not need anymore. And now you see where you're left with moles, right? That's the last unit. So now let's plug in everything that we know. 3.5 times 1 divided by 0.0821, and then divide that again by 310, and your moles are 0.137, but we only need 2 of those, so 0.14. All right, 0.14 moles of whatever this of gas. Now, you all know the name of the gas, right? If you inhale oxygen, you exhale carbon dioxide. So if I ask you as an advanced question, I could easily say, calculate the grams of the gas. But I did not tell you what the gas was. But I am testing your ability to see if you can read between the lines of the problem. So if I ask you to calculate the gas in grams, you would take that 0.14 moles of carbon dioxide, and we're going to use the molar mass from the previous problem, divide by 1 mole of carbon dioxide, and cancel out your units that you don't need. And if you plug that in, 0.14 times 44.01, you end up with 6.2 grams of carbon dioxide. All right. Again, that's just another way in which your professors could test you to see if you are really on your A game. Okay? Again, it's not a trick. It's just, general chemistry. It does involve a lot of stuff. And if you all are going into the engineering program, or even majoring in chemistry, or even a chemical engineering major, or some type of STEM, if you're taking General Chem 1, the expectation is that you know how to put all of this together without being told, without giving you all these extra clues. But if you're in an introductory chemistry class, I may give you a little extra just because. Okay. Now, we're going to solve for volume in this next problem, right?